Picture this, it is 2014, and every company is drowning in data. The reigning champion, Hadoop, is slow, complex, and painful. Then, a UC Berkeley research project called Spark emerges, promising speeds up to 100 times faster. It wasn't just an upgrade, it was a revolution. Today, it is the backbone of Netflix, Uber, and Facebook. But why? What made this tool so significant that it completely redefined an entire industry? Let's dive in. Spark did not win by being fast. It won by pretending CPUs are infinite. But Spark's breakthrough wasn't just pretending CPUs were infinite. Its real genius was daring to ask, what if the slow, grinding disk wasn't the center of the universe? It promoted RAM to the starring role, treating it as the primary workspace, not a sideshow. Data was now processed in memory, not through a disk bottleneck. That was the paradigm shift that broke MapReduce back. Imagine your computer's most expensive, lightning-fast component, its RAM, sitting idle while your workflow chokes on sluggish disk reads and writes. That was the reality. Spark said no more. It fundamentally re-architected data processing to work in memory, making the CPU's full power finally accessible. That single change turned hours of waiting into seconds of execution. Every job was a traffic jam of disk I/O, a constant drag on innovation. You had the processing power, but you were feeding it through a straw. Spark did not just tweak the engine, it built a new highway in memory. This shift from disk-bound to CPU-bound processing is the seismic event that unlocked real-time analytics at petabyte scale. That wasn't the real MapReduce revolution. This was. Imagine if every query forced you to read a physical book. MapReduce did that. It choked on the slow, grinding disk I/O. Spark said, enough. By loading data into lightning-fast memory, it turned agonizing batch jobs into near real-time conversations with your data. This wasn't an upgrade, it was a complete paradigm shift in how we process information. But think bigger than just speed. This wasn't about doing the same work faster. By making data instantly accessible, it fundamentally changed what was possible. We could now experiment, iterate, and explore in loops that were previously unthinkable. It unlocked interactive analytics and turned data from a static asset into a live, malleable resource you could truly converse with. So, we stopped talking about data in the past tense. That's the real breakthrough. Imagine asking a question, seeing the result instantly, and immediately asking a deeper one. This created a continuous, fluid dialogue with your data. It shifted the entire paradigm from a batch reporting mindset to live, collaborative exploration. Spark isn't about speed, it is about destroying an entire era of data systems. Look at what came before. The Hadoop ecosystem was a fragmented nightmare. You had one tool for yesterday's data, another for SQL queries, and a completely different system for live streams. Engineers were drowning in complexity. Then Spark arrived with its revolutionary vision, a single, elegant engine for every workload. This unification did not just simplify things, it set a new, inescapable standard. Picture what that unified API means for you, one seamless code base handling every task, erasing boundaries between batch, streaming, and AI. This coherence is its superpower, eliminating integration hell and letting your team innovate, not just maintain. You are not patching systems together anymore, you are building the future on a single, foundational rock. Forget stitching disparate frameworks, a guaranteed future of brittle pipelines. Spark gave you a single, sovereign core. You stopped being a glorified plumber connecting leaky tools and started being an architect. That shift from integration burden to creative freedom isn't just convenient. It is the tectonic crack that defined modern data engineering. Your entire philosophy changed. Apache killed Hadoop quietly. Spark did not just win, it changed the rules. This was a revolution in productivity. Instead of drowning in endless XML files to describe a job, you could now express the logic in real code. The map, the filter, the transformation, it was all right there in your editor. You weren't just configuring a system, you were programming it, turning complex workflows into clean, testable, maintainable functions. And it empowered you. Suddenly, you could think in data flows, not in brittle configs. Your logic lived in functions you could debug, version control, and truly own. This shift wasn't just about speed, it returned creative control to the developer, making big data engineering feel like genuine software craftsmanship for the first time. The proof is in the numbers. Within 5 years, it became the most active project in big data history, with over 1,000 contributors from hundreds of companies. That's a tidal wave of collective intelligence, directly fueled by making development intuitive. They did not just adopt a tool, they built an entire ecosystem because it finally made sense. Spark's secret. It cheats by doing less work than you think. Spark obliterated the old, expensive hardware locking. You no longer needed massive, proprietary clusters and armies of engineers to process terabits. This unlocked a tidal wave of innovation from smaller teams. Your laptop could now prototype what once required a data center, making ambitious data products a reality for everyone. But that's just the hardware. The real magic. You could now build models directly on your live data instantly. This wasn't just fast, it was iterative. Data scientists could test, refine, and redeploy at the speed of thought, breaking the agonizing cycle of waiting for results. It transformed machine learning from a batch experiment into a dynamic, continuous process. That dominance in the cloud created a powerful network effect. Suddenly, an entire generation of engineers and data scientists learned Spark first. It became the universal language of big data, erasing the fragmentation of legacy tools. When everyone speaks the same language, innovation accelerates. That's how a piece of software did not just run jobs. It unified an entire industry. Spark's significance isn't just about speed, it is about enabling a new era of data applications by moving computation to memory. It consolidated a fragmented ecosystem into one unified platform, simplifying big data architecture for everyone. Try running a simple Spark analysis on a sample dataset to experience its expressive power firsthand.